Hello friends, welcome back. In this video, we will talk about Kafka supports what kind of a use cases. Mainly it supports two kind of a use cases when we want to create a data pipeline between two systems and we want to perform real-time event processing on a data. So for this kind of a use case, we need Kafka. Let's see some examples, right? Let's say suppose you want to have incremental ETL and where you are getting the data from one system and you want to store in target system and it's incremental ETL. So what we can do, we can use Kafka for this kind of a use case. We can also use Kafka for real-time analytics, right, like Twitter trending or buzz on Twitter, right? For this kind of real-time analytics, we can use Kafka. We can also use Kafka for reporting dashboard or infrastructure dashboard, right? It's like you want to have a dashboard which can talk about the current status of our infrastructure, how much memory is consumed, what is the CPU utilization, what is the network bandwidth, right? So for this kind of real-time data, we can use Kafka. Kafka can also be used for real-time decision making. Let's say for like fraud detection, right? Within a millisecond, we want to find out any fraud is happening online or not, right? So for this kind of a scenario, we can use Kafka. Also, we can use Kafka for raising alert, right? Let's say consumer is buying some product, right, and it is about to go out of stock, right? So you can raise an alert on UI. Based on that, user client or consumer can take their decisions. Okay, so these are the mainly major real-time examples of Kafka. Let's see what problem Kafka is trying to solve, right? Let's assume we are not using Kafka. We are using we want to have a real-time data pipeline between multiple systems. When I say the multiple system, right, where you have one system which are producing those events, and there are some consumer applications which are consuming those events, right? So what is happening here, when I say event, in any application or any consumer application or real-time applications, right, when consumer click on something or like something, it changes the meaning of that product, right? That means most of the users are liking those products. So you want to pass the data to some other application. Based on that, recommendation services can be invoked or new product can be shown to users, right? So for this kind of system, we need to pass an event. So there are three stages in any real-time event integration. First, event generation. Second, transporting those events. Third, processing those events. So what we are talking about here, event producer, event consumer, and how they are transferred over a network. If you see in this example, I'm taking an example of one travel agency, right? This travel agency is online across country, right? Like India, China, US, or Europe. And we have other microservices, customer management, finance, itinerary, and some analytics is being performed. So suppose one customer is going online, he's booking at the travel agency, right? At India, he's booking his travel plan. So what happened? He's sending a data in real time to these consuming applications or services. So what is happening? Data is flowing from one system to another system, but this integration is very tight coupled. If you see in this diagram, right, one system is connected to multiple systems. What if the finance system goes down at that moment, or customer system services goes down at that moment? So there will be no real-time integration will be performed. System will be down for that given moment. So how can we solve this problem? In this diagram, what we say, we call stream mesh. Why it is a mesh? Everyone is connected to everyone. If suppose example, tomorrow we want to evolve our application, right? I want to change the JSON contract between two systems. So in that scenario, all the systems which are tightly coupled needs to update that. That is why this solution where two systems are directly talking to each other and they are processing the real-time events is not advisable, and this solution cannot sustain for long. But how to solve this problem? We can solve this problem, let's say, with a simple example, right? What if I introduce one database in between? Now the tight coupling is gone. Producer is connected to database, it isn't directly talking to consumer, and consumer is not talking to producer, it is talking to database. So, but problem with here is that database is data at place, it is not data in motion. So data is not directly going from one system to other system. First is going to some common database, and from the common database consuming applications are reading it, right? And though we have couple of distributed database, but this solution also is not performing the real-time analytics, right? It is not processing the real-time data, is going from one server to database, sitting there for a couple of minutes or seconds, and is a bottleneck on this database, because as soon as your consumer application keeps on increasing, SQL query will be executed a lot, right? DB connections will be established. So this solution cannot be expanded for the real-time processing. Yes, it can be used for the reporting purposes and all, but it cannot be used for the real-time analytics. So what the solution is? So we have to find one software or program or framework which can solve this problem.